All right. All right, yeah, thank you for the introduction. Yeah, so I'm going to talk a little bit about Terraform provider development. And so Terraform provider development is sort of a deceptively simple thing to do. You know, Terraform at its base level does about 5 things, right? All the CRUD operations, create, read, update, and delete, and then importing resources, which is kind of a special case of reading. But 9 months into working at Aviatrix and working full time on a provider, I'm still finding hidden gems and hidden traps that I find in provider development. And also recently, version 2 of the Terraform Provider SDK, which is kind of the toolkit for creating providers, was recently released. And so this adds even more functionality to what you can do when you're creating a provider. So it was at that point that I decided, okay, I really want to dive deep on how are other people making Terraform providers, and also what are all these new tools that were released in version 2 of the SDK. And so that's why I decided to do this talk, as a way to teach myself and also teach others. And when I say a modern Terraform provider, what I mean really by modern is, let's try to use the best tools that are available to us. And also let's learn from the successes and mistakes of those before us and see if there's any useful patterns that we can glean from them that we can follow. And so our agenda to do that is to, first, we're going to talk about maybe why you would want to write a Terraform provider, a little background on what Terraform is and how providers interact with Terraform core and the Terraform tool. And then we're going to do a little walkthrough of sort of how could we write a modern Terraform provider. And this won't be an exact tutorial of how to write a provider. There's a ton of great resources, and I'll share some more at the end. But really, it's more of picking out sort of what's new and what are sort of the useful patterns that I found throughout a lot of different providers and my own experience of writing the Aviatrix provider. And so a little about myself. I've been in love with software development since I was in high school. And I've done a lot of things from web development, embedded devices, and now recently with cloud infrastructure and cloud networking at Aviatrix. And Aviatrix is basically tries to offer a single pane of glass for all your cloud networking. And we do that, the main interface we do that through is our Terraform provider. And I think right now we support over 7 different clouds that you can manage all your networking infrastructure all through a single provider interface. And you can reach out to me with any other questions or anything in the chat or through Twitter. And so let's talk about what is Terraform. So you could call it infrastructure as code. You could call it the thing that makes the DevOps people really happy. But recently I was actually asked this question by my dad, whose greatest technical strength is really posting to Facebook at a very rapid pace. So I wanted to explain to him in simple terms. So I found a good analogy to use is that we could think of cloud providers really as like offering a buffet. So each cloud provider sort of gives you a buffet of options and through APIs of things that you can take on and things that you can use. And what it's like without Terraform is that you kind of grab a plate and you go up and you take things one at a time. You kind of build your own little bespoke, beautiful plate. And that's great when you're a single person. However, most of us are working in companies when we're using Terraform. And that's sort of like you came to this restaurant with 10 of your lazy friends, and they all tell you just to go figure it out and get all the plates for everyone and make modifications here and there, and you bring one back and they don't like it, you have to go back. And it can become really tedious and cumbersome and also prone to mistakes when you have to do things manually. So instead, what Terraform lets us do is sort of have this amazing waiter who will just come and say, okay, write down your order, exactly what you want, and I'll go figure out all the details. And this makes life really easy for you and your lazy friends. And so to take this analogy a little further, you could think of each of cloud providers as sort of the restaurants, and that actual waiter who knows all the ins and outs of that restaurant would be the Terraform provider. And that's the thing that you have to implement if you want Terraform to be able to manage your resources. And so is Terraform providers then really just for big cloud enterprises, Amazon and Google and the like? No, actually, if you this is a screenshot of the first page of some verified providers, which are not even written by HashiCorp. And you can see at the bottom, if you look real close, there's over close to 800 different providers. So these are pretty much anything that is API driven and has some sort of state somewhere, then you can represent it with a Terraform provider. And I mentioned that it has to be stateful because certain actions, pretty much anything that in a GUI would be like a button press, like do this once, is really not suitable for Terraform. So really anything stateful, and that's API driven, you can use Terraform to represent that. And so how does Terraform do that? How does it support, over 800 different providers here? Is HashiCorp maintaining 800 different provider binaries? No, actually HashiCorp did something really smart, which is to make Terraform have an extensible architecture. So if you look at this great diagram that's from Seth Vargo in his article about how he managed Google Calendar with Terraform, you can actually see that Terraform core interacts with plugins through this RPC-based plugin interface. And then those plugins use a client library of their choice to actually talk to the upstream APIs. And this diagram points out that it's HTTP for talking to upstream APIs, but it actually could be anything. So pretty much anything that's an API that has state, you could use Terraform. And so that's a little background on Terraform, but now I want to go more into sort of how we'd write a provider today and sort of what are the, I guess, hidden gems or hidden traps you might want to look out for along the way. And we'll go through these 5 different categories and we'll talk about a few concepts and ideas in each category. So we're going to start with just talking about provider tooling. And again, this is going to kind of cover all the newer things that's in each of these concepts and some of the smaller patterns and details from each of these concepts. To get a more broad overview, there's definitely a bunch of great documentation from HashiCorp, and then also another great talk about Terraform provider development is by Eddie Zaneski from DigitalOcean called How to Write a Terraform Provider for Just About Anything. And I'd highly recommend checking out that talk to get a more basic ground cover overview of Terraform provider development. So for talking about tools, we're going to talk about just provider tools. So in our architecture diagram here, that's just this part that talks to Terraform core and then interacts with the client library. So how would we start a Terraform provider today? Well, I really love this quote from one of SourceGraph's co-founders, and that's the right example is worth 1,000 lines of documentation. And I really love that quote because it really seems to ring home true to me, because definitely whenever you find the top voted Stack Overflow answer, it's always the one that's like a very clear example of exactly what the question asker wanted with a little bit of explanation. But really it's in the example that you can learn a lot. And so one of the best examples for writing a Terraform provider is this Terraform provider scaffolding. And this is an awesome repo that kind of lays out a template for how to start a provider and also uses a lot of those cool new SDK version 2 features that were recently released. And so this is definitely where you'd want to start if you're going to start writing a Terraform provider today. I wish I had this when I was learning because it's a great example. And it's also uses a neat GitHub feature of being a template repository. So it's just one button click away from pulling this template and cloning it onto your own account and getting started. And so our main tools is actually the provider SDK, like I've been talking about with version 2 being released recently. And I put this little toolbox here just to iterate that, the SDK is sort of really everything that we have. It's the whole toolkit for interacting with Terraform. And so you really want to learn these tools really well and understand how they work, especially since the SDK behavior it's well documented, but it's not always what you would expect. Terraform goes through sort of the different stages of create, read, update, and delete. And sometimes a simple SDK function that says maybe get an attribute from your state, it can maybe behave differently depending on whether you're creating or reading or updating currently or deleting. So it's important to really understand how these tools work and play with it a lot to get a good understanding of it. And so I want to dive deep on sort of the version 2 features that I think are really great from the provider SDK. And so we're going to start with context-aware CRUD functions. And so what I have here is the type signature for the create context function. So this is the function that you would need to implement if you want to write a provider. And this is what Terraform would call when it wants to create a resource of whatever you defined as your resource. It'll call this function to create that thing. And the important bit here is that now we get to have this context.context as the first argument. And so if you're unfamiliar with what a Golang or Go context is, it basically carries information that is scoped to the specific request. And so that information could be anything that you put in there, any keys and values that you want. But the most important information is whether a context has been canceled or not. And so a context could be canceled by either someone manually calling the cancel function, a deadline has been reached, or a timeout. We've reached a timeout. And so this is great because in Terraform, it's going to pass us this context. And then, for example, if the user hits Control-C at their terminal and doesn't want to keep applying some Terraform configuration, that'll cancel the context and that'll bubble down to your function calls, and then it can save you from doing unnecessary work. For example, if some resource is going to take 3 different API calls to create, but by the time you're on the second API call, the user has already hit Control-C and is walking away from the computer, and they no longer care about the results of this apply. This will help you from doing excess work and actually continuing to call APIs that are unnecessary. And so just sort of the key concepts of the context awareness is it carries request scoped information, and it's cancelable through timeouts, deadlines, or manually calling the function. And also some cool kind of look into the future. If you look on the Terraform SDK repo, you'll see a proposal currently out for how we can improve logging using this context. So the current state of logging in Terraform is that sort of logs from all levels, from the Terraform core to your provider to your HTTP library, are all sort of mushed into a single stream. And your best bet of finding your logs is to grep through it, looking for your unique string somewhere in there. But the latest proposal that came out is to actually pass a unique logger in through this context. So we eventually may be able to actually have much cleaner logs by giving each resource, and each layer can have its own dedicated logger. The next feature I want to talk about is diagnostics. So a diagnostic is sort of, you could think of it like a replacement for errors, like a little bit better errors. If we look back on our create context func signature here, we'll see that it returns a diag.diagnostics. And that's just simply a slice of diagnostic objects of this struct. So you have a severity, which is either a warning or an error. And you have some summary and details, which will be shown to the user. And then you also have the attribute path. And this attribute path is really cool because this allows you to actually pinpoint to the user exactly where the issues they're having came from. So for example, we can see here that I'm giving a warning telling the user that they're trying to do something really odd. And I can tell them exactly the path to which attribute is causing the issues. And so we can see here that this is an example of what would Terraform print out for us. And it gives the user a nice yellow warning, and then also underlines exactly the name. This name attribute is the one that was causing issues. And so this is really, really great because there's often times when you want to give a warning to the user, but you don't actually want to fail the apply immediately with an error. So this is really helpful for just really sharing as much information, as much relevant information to the user as possible. And finally, for the V2 features is debugging. So now we're able to actually debug Terraform providers. Previously, it was just you were left with your one messy stream of logs to get any debugging information out. But instead, now we can optionally start providers in debug mode, and we can actually debug them with Delve, which is Go's pretty much the state of the art of Go's debuggers, and it allows you to set breakpoints and inspect the current state and all those great features that you love from a debugger. And so keeping going with our toolkit from the SDK, the next is the acceptance testing framework that the Terraform SDK offers us. And so the acceptance test framework really allows us to have as complicated tests really as we would like. And so in your Terraform provider, you can either have some really lightweight testing, or you could have some sort of full regression pipeline of user workflows and exactly how they're going to use the resources. At Aviatrix, we have a QA organization and team, so we leave all those like full regression tests and everything to the QA teams. So we keep ours very lightweight, but the acceptance test framework is definitely useful. Even if you're just doing lightweight sort of sanity tests, it can be really great. All right, and that covers most of our provider tooling. And now we're going to kind of look at some patterns that I found throughout other providers, and then also in my own experience writing the Aviatrix provider. And so the first one I want to talk about is defining your own marshaling function. So marshaling, another word for that could be encoding or decoding. And really, this is kind of, when you think about Terraform providers, really the core of it is marshaling data between your resource, the resource data that you get from Terraform core, and then marshaling that into a form that your API client library will like. And I find it's really super useful to keep all of this information of how resources map from your configuration into the actual API objects that are expected. And it's good to keep it all in one place. This really helps when a new developer comes on the team and they want to understand, okay, how does all the attributes in this resource really map to the backend? And it gives you a single place and a single source to look at that. Another pattern that you might see if you're reading some Terraform providers is returning the read function. So this was something that was really confusing to me at first, and it's sort of loosely mentioned in the documentation and some tutorials, but not really fully covered. So the main thing with returning a read function, what this allows us to do is to allow for partially created or updated resources. Let's say, for example, you have a resource that is going to take 3 API calls to create it. And let's say the second API call has an issue. Normally, you would say, okay, that second API call, return an error, return that error, and Terraform will tell the user that something went wrong, and they taint the resource. And by having it be tainted, now the only option for the user is to now destroy and recreate that resource. But instead, if we know that we're in a safe space, maybe after the first API call, that resource is created just fine, and the next 2 API calls are not as mission critical, we can actually sort of tell Terraform by returning the read function to, just tell the user that everything went okay, but just let's keep track of our progress up to this point. So the read function goes to the API and pulls down all the information about the currently created resource. And then that'll give the user the option to apply their configuration again and see what are the differences between what actually got applied and what is still different from their desired configuration and what is actually deployed into reality. The next thing that I want to talk about is optional and computed attributes. So in Terraform, you'll read the documentation and they'll say, okay, there's required things, there's optional things, and there's computed things. And required and optional are pretty self-explanatory. Computed just means that this is not a value that the user should provide. Instead, this value will be generated and the user can basically only read it. So it's basically a read-only value. But what they don't tell you is that these can actually be combined. And so an optional and computed value is something where the user has the option to provide a value. And if not, one will be computed and be able to be read by the user. And so this is super useful for when you have those situations where, maybe a default value is actually unknown at the time. For example, maybe an IP address will be assigned to this resource at some later time, or the user could provide their own IP address. And so this is one of those things that you kind of only figure this out by reading other providers and seeing that this type of thing is possible. The next pattern I want to talk about is reusing common schemas across attributes. And so this is an example pulled straight out of the DigitalOcean provider. And so what they have here is a function that returns a schema that is basically their tag schema. So a lot of cloud providers allow you to tag your resources, which are basically key value pairs. You can put whatever information you want. And so DigitalOcean kind of consolidates all their tags under a single schema. And this makes it so that these tags will be really easy for developers to add to other resources. It'll always be very consistent. And this is something I recommend. If you can pull out common parts of a schema, definitely do it. And also, not DigitalOcean, they take it a step further. It's not just the schema. They actually basically built up this whole tags library. So you'll see this, they offer this validation function, validate the tag. They also have a whole library of how do we create tags, read them, update and delete them, and then all of that functionality is shared across resources. So this is a good example of trying to reuse common attributes that are going to be common across different resources. And so a few more that I want to touch on, a few more useful patterns would be to use a consistent resource code structure. This kind of goes along with having a single marshal function for marshaling your resource data into your API structs. And this is really helpful when you're hopping in to debug a problem. If the code structure looks the same across all different resources, it's really easy for you to pinpoint where you want to look depending on what your problem is. Another thing is don't try to do too much in a single resource, because oftentimes the abstractions will leak out and will cause problems. So for example, at Aviatrix, we have the concept of a spoke gateway and a transit gateway, which is like the hub. So one hub can have many spokes, but each spoke originally could only have one hub, one transit gateway to attach to. So the developers put in to the spoke gateway, put a single string that says, this is the attached gateway. And so, that seemed to make sense. It's just a single field added onto the spoke. It's a different API, but they thought that's okay. But then later, someone had the great idea of, okay, what if spokes could have multiple transit gateways attached? And so now that single string was doing double duty of now acting as a comma separated value string. So you could put in multiple names of gateways for this one spoke gateway to attach to. And then later there was issues where the timing of the creation of these attachments was off, because every time the spoke was brought up, it immediately would try to attach to its transit gateways, and that could cause issues. So instead, eventually we ripped this out and create its own standalone resource of a spoke transit attachment, and now that solves all of our problems. And so really the key is to try to match your upstream API as close as you can. Or else you'll have some abstractions that will end up leaking out on you. Also, another thing is to have an example provider on your local machine for testing your assumptions. So you could steal mine, and it's really nice to have an example provider nearby to test out if the SDK is behaving like you think it would. Okay, nice. And then next we're going to talk about API clients. And so that's the client library portion here. So a few things needs to be in Go. We should design for context awareness in mind, even design with diagnostics in mind. What are times when your API could return just a warning instead of an error, and how we can show that to the user and make it useful. Another concept is having a thin provider and a fat client. So what this means is that the provider should really be just responsible for handling what's the schema, what does a resource look like, and then marshaling of that schema data into API structs that the API can accept, and then passing that along to the client. And so really you want to keep all your business logic and all your domain specific knowledge, keep all that in your client library, and keep your provider as thin and small as possible. This will really help with debugging and everything in the future. And also generate your API client if possible. There's a lot of different API definition languages that allow you to generate clients, and that can save you some work. And really, an API client is really important, because your Terraform provider is basically a reflection of your API client, and your client is a reflection of your API. And really, your Terraform provider can really only be as elegant and as smooth to use as your API itself. And so you should really think about designing with the API, design with thinking about the API first. And this is especially useful if your product is going to be primarily used with Terraform. It's really important to think about how your APIs work, and make sure that they're elegant and able to work smoothly. And so really, if you can also defining your API, like we mentioned before, using one of these API definition languages can be really great, especially if you can actually define your API so well that you might not even need Terraform provider developers to write it. And that's exactly what Google Cloud Platform does by actually defining their APIs so well and so specifically with this Ruby DSL that they have, that they can actually generate Terraform providers, and not only that, but also generate Ansible plugins and inspect plugins. So if you're able to really define your API really well, it can actually save you a lot of headache down the road. All right, and finally, let's talk about some documentation. So key points on Terraform documentation: users will, of course, copy and paste your examples and put them directly into their Terraform configurations. So really, you got to make sure that you have a bunch of great examples that show exactly how you intend for this resource to be used. And also, users will definitely forget what version of the documentation they are looking at, and they'll try to use features that maybe don't exist or have different behaviors in their version. So at Aviatrix, we always add a little extra note to our attributes saying, this was available as of this provider version, or this changed behavior in this provider version. And that can really help people to understand what attributes they have available depending on their version. And also, if you can, again, let's let the robots write some of this stuff for us. So with the newest version of the SDK, we're able to provide metadata about our resources, our attributes, all in the provider code. And then this can be pulled out and generate actual markdown documentation for you to be shown to your users. And so this is another great way of keeping your everything as a single source of truth. So there's like a single place where this description of this attribute is defined, and it's in the best place possible. It's right next to where, it's right in the code where that attribute is actually defined, and that's where you'll find the documentation and description. So it really helps developers to not forget about updating that documentation when they make a change. And finally, just general Go project stuff. You want to use a linter, definitely do that as early as possible. Automate it all with continuous integration. Use GitHub Actions. It's free. It's really easy to integrate with your GitHub projects. And when we're finally ready to release, we automate all that up using Go Releaser. And HashiCorp has great tutorials on how to use Go Releaser to release your Terraform provider and do it consistently and make sure everything is all nicely signed binaries for all the different platforms you want to support. All right, and so don't we love seeing a fully completed checklist? So that's all the concepts I want to talk about with Terraform provider development. Hooray. And so I hope that if you already have been developing a Terraform provider, you learned something new. And if not, then maybe you got interested and maybe want to try it out. And you can use some of these resources to continue your learning.